All right, so yeah, we're going to just talk about the definition of a derivative. So we can define a derivative, and we'll get into what they mean in a little bit, but just for now, we can define them using a limit. And the following equation. So if we imagine like just a random curve, okay, then f of x at some value would be, let's just say, I don't know, somewhere here. So this is our x, and this is f of x is the height at that point. And then f of x plus h, we're just adding some number h to it. Let's say that's, I don't know, right here. Could be anywhere, because we could define h as anything. Oh, this is x plus h. So the distance between them is h. Okay. And then, now, if we start to take this limit and let h go to 0, then what you can imagine is this second value that we have here for f of x plus h will start to approach f of x. As h goes to 0, it just becomes f of x. And by doing that, what we are actually getting is the rise over the run. So this f of x over h minus f of x is basically this distance right here. And h, as we said, is the horizontal distance between the two. So we're getting the rise over the run, or the slope, between these 2 points. And then, as we said, as we start to take that limit and it gets closer and closer to f of x, then we're actually getting the slope at that exact point. So normally, if we go back to Algebra 1, you have the slope of a line, right? And that is your rise over your run. And your slope formula is m y2 minus y1, x2 minus x1. So it's defined by 2 different points. And if you look, this is actually the same thing that we have right here. y2 minus y1, and then h is just x plus h minus x. So it's the exact same thing, but the difference is with this limit, we are no longer defining it at 2 points as h goes to 0, because it's the slope at that single point, f of x. And what that allows us to do is, well, I mean, if before I said this, I asked you to find the slope of this curve, you wouldn't really be able to do it. You could maybe find the average slope between 2 points, but the concept of slope in Algebra 1 does not allow for anything outside of straight lines. To find the slope of a curved line is whenever we start to have to use calculus. Because you can imagine, like, the slope at this point, if we did the tangent line to it, which we'll come back to what that means, the slope at that point is going to be different than the slope over here. It's going to be, something kind of like that. It changes as you go up the function. So that's why we have to use this concept here of the limit. So we're basically taking the limit of the slope function. And so let's do an example. Let's find I forget how they define this in the books, but I think they usually say y prime or dy dx, but they're the same thing. It's the derivative. Y prime, like that, or dy dx are the two notations that you use for the derivative. Like that. So it's asking us to, or I am asking us to find the derivative of x squared. Okay. So to do this, first, with any of these functions, you want to find y of x plus h. And literally all you have to do is where you find x, you just plug in x plus h, like so. And then you just plug it into this formula here. So the limit as h goes to 0 of f of x plus h, which is x plus h squared, minus f of x, which is just the normal function, x squared, over h. Now, we can't just plug in h, the limit as h goes to 0 right now. And why can't we do that? Well, we don't.
It's not like a number.
What would happen if we plugged in h goes to 0 right now?
Then it would just be the line.
Well, let's think about it. Let's just try it. So we plug it in, we get.
Oh, it's just 0. Or no, it's f of x.
Right? So h is 0 on top. So we have x squared. Well, actually, we need to FOIL this out. So let's, but look at what will happen on the bottom. If h goes to 0.
Then it's 0, and that doesn't.
Yeah, that's undefined.
Okay.
So that's a key thing here whenever you're doing these problems is h on bottom should cancel out. If it doesn't cancel, then you've usually done something wrong. So yeah, let's FOIL this x plus h out. So that'll give us x squared plus h squared 2xh, good. And then minus x squared over h. So the x squareds will cancel. And then we'll have h squared plus 2xh over h. Oh, and I keep on forgetting this, even though I told you not to do it, so I'm breaking my own rule. Keep writing the limit, yeah. Okay. And now we can see, since both of these terms on top have an h in them, then we can cancel the h on bottom. And so what we're left with is the limit as h goes to 0 of h plus 2x. And now if we plug in h goes to 0, well, then that's just 0 plus 2x. So it's 2x. And yeah, 2x is the derivative of, if y is equal to x squared, then 2x is the derivative of that. The rule for polynomials is the derivative of x to the n. So n can be any exponent, is n times x to the n minus 1. So we had x squared. So the 2 comes down, and then the exponent was 2, so 2 minus 1 is just 1. So that's how we got 2x. So whenever you get into calculus, you won't be using this formula. You'll be using derivative rules like this one. But this is a good way to start out with derivatives because it shows you where they come from and where these rules come from. So let's do another. So we can see, by the way, if we plug in if we draw our original function, x squared, it's good to think about what we just got. So this is our original x squared function. And our result is 2x, but what does that mean? So that is the function that will give us the slope at any point. But if we want to see what that means, like let's say we plug in, we want the slope at x equals 0. So the slope at this point, it'll be a horizontal line. And if we plug it into our function here, our y prime of 0, well, we get 2 times 0, which is 0, which is a horizontal line. If we want the function or the slope up here, well, the slope is going to be something kind of like that, right? Mm-hmm. Which I said before, tangent line, but do you remember from geometry what the concept of a tangent line is?
It's like right there.
It's like right there, yes. It's a line that touches the function only at one point.
Okay.
And that's how derivatives are defined, is that they are the slope only at that one point, and that creates a tangent line. But yeah, at the point that's like x equals 2, we just plug it into our derivative, our formula that we came up with. So 2 times 2, that'll give us 4, which 4 is a very, a pretty steep slope, which is what we expect here. So, yeah. So again, yeah, you can plug in any point here, and it gives you the slope on any point of this function. That's what a derivative is. Okay. All right, so let's do another one. Let's say we have f of x equals x to the fourth minus 2x squared. Okay. So this will look something like, just very roughly, something like that. It might have different root points, but it'll roughly have that behavior where it goes to infinity at either end. Okay, so what would f of x plus h be?
X or 4x. No.
So if we go back to the original problem, remember it's just for any x that we see, we just put in x plus h in parentheses.
Yeah. So x plus h to the 4.
Yep. And actually, I want to change this because that's going to be a nightmare to foil.
Perfect.
So this will be something more like that. Okay.
Minus 2x plus h squared.
Oh, yeah. Good. Just testing you. Okay. So then our derivative is the limit, so h goes to 0, again, of f of x plus h. So that's x plus 4 cubed minus 2 x plus h squared minus f of x, which is x cubed minus 2x squared. Over h. Wait, why did I write 4 here? H. All right, and then let's see what we got. We can FOIL this stuff out. So x, well, we know what x plus h squared is because we already FOILed that. So it'll be like x plus h times x plus h squared. So that's oh god, this is a long problem. Like I was telling you, I'll probably put one like this as a bonus on the test. It will not be this long, don't worry. It'll be a little bit shorter.
Okay.
All right. And then if we FOIL this first one out, what will that give us? We'll get it x cubed plus 2x squared h plus x h squared plus hx squared plus 2x h squared plus h cubed. Good God. Oh, yeah. And then minus 2x squared minus 4xh minus 2h squared. And then we can just get rid of these brackets. Minus x cubed plus 2x squared. And now here's another important strategy thing I wrote up here, that h on bottoms should cancel. Also, all terms containing only x should cancel as well, because that will allow the first thing to happen. Because if we have terms on there that don't have an h on the top, then we can't cancel that h on the bottom. Yeah. Luckily, a lot of this will cancel. So we have an x cubed and an x cubed, minus x cubed, so those will cancel. We have a 2x squared and a minus 2, yep, so those will cancel. Okay, so none of the other ones will cancel, but we get h, one of every h on top will cancel. So we get 2x squared plus xh plus 2xh. Oh, we could have combined these, but whatever, doesn't matter. Plus h squared plus x squared from here plus 4x minus 2h. And what's going to happen once we plug in the h goes to 0? All the h terms are going away. So we get 2x squared plus x squared plus 4x, or 3x squared plus 4x. Actually, that should be minus, excuse me, yeah. And if we look at the derivative rule for polynomials, it becomes, basically the exponent comes down and we subtract 1 from it. So that would become 3x, subtract 1 from the exponent, squared, minus the 2 comes down, so that'll be 2 times 2, 4x, subtract 1 from the exponent, and which is exactly what we got. So that's why we use that in calculus rather than going through all of this.
Yeah.
It's much easier.
So like for the bonus on the test, does all the work need to be shown?
Yes,
Okay.
although I will not give you one this
Yeah.
long. It'll be closer to something like the first one. It may be like x cubed, but I won't put 2 terms in the x cubed like that. That was overkill. Okay. So that's it for